welcome to E-Trees Enhancements. Today in this video we're going to be focusing on pencil barrels, specifically the effect of suppressors on pencil barrels to see how much droop or at what point do we start getting droop when we attach weight to the front end of the barrel. Pencil barrels have been a thing since the beginning of the AR-15, but they have also recently started gaining up a little bit more momentum after the What Would Stoner Do 2020 project, which has ran both pencil barrel, a Faxon pencil barrel, and ballistic advantage pencil barrel. They started originally with the Faxon pencil barrel, but they have now moved on to the ballistic advantage. In this case, we're going to be using two different barrels. They're both pencil barrels. They're both from Faxon, but one of them is a 16-inch and the other one is a 10.5 inch. We are gonna try to figure out, number one, at what point does it start flexing and how much flex do you actually get from a certain amount of weight per suppressor. Now these weights are all going to vary because not all suppressors are equal. That's why I'm doing an incremental weight. This could be as simple as like a Surefire Warden that could affect the weight. How much will it affect is really dependent. At the end of the day, is really dependent on what you're running. You will have this information, I will not, so I'm going to simplify all of this by just doing a range of weights. At the end of the video, I'm going to upload this information into an Excel file that I will share in the description of the video. So this whole idea started on the fact that I have a recce build that runs a pencil barrel so that I can get a better balance of everything by being able to run heavier objects with still a better balance as if I wasn't running those heavier objects like an LPVO with this cloud defensive frame. Well, also, I don't know if you guys noticed, there's a chamber flag on it, so I'm perfectly safe to move around in here. It's not gonna fire. And it's also unsafe. As far as what the rifle is, like Flannel Daddy says, to butt, we have a rugged suppressor's flash hider. Ideally, I would love to be able to put the rugged suppressor on this so that we can get a measurement or comparison of what it would do, but the ATF is at day 345. I'm still waiting on it. So with that said, we're going to use a different method, which I'll show you in a little bit, but again, starting tip to butt. Rugged suppressor's flash hider. Got a cloud defensive rain here. This is a full size. Faxon pencil barrel. This is a full pencil barrel, not the gunner profile. We got a superlative arms, adjustable gas block. This is a clamp-on model. I believe in the clamp-on setup, not the set screws. I'm going to make a video into potential deflection of gas blocks with set screws versus the clamp-on, but we'll get to that in the future. Anyway, BCM MCMR 13. Got a BCM upper receiver. This was a thermal fit, so I did have to press fit the barrel into the upper receiver. Got a Rubber City Armory nitride bolt carrier group with 9310. Chose it because of 9310 and because it's nitride, just easier to clean, easier to work with. Got a Palmetto State Armory $40 shipped lower receiver that I purchased in 2018. JP Silent Capture buffer, which is amazing. BCM stock, BCM grip, and I've got a Geisley single stage precision trigger on it that I absolutely adore. Moving up, I have the Vortex Viper PST 1-6 with a Seekins Precision MXM mount. That is summary for the rifle. Moving to the 10.5. 10.5 does not have an upper receiver, so instead it does have an upper receiver. It's a little different because I don't have a handguard for it, so I had to make a contraption, which I'm also going to show exactly what's going on with this setup. I have the contraption that holds onto the dial indicator, which is how we're going to measure it. I'm going to load the barrel at the tip. This is just a Faxon 10.5 with a Faxon generic gas block that's been torqued to 28 inch-pounds. Barrel nut has been torqued to 45 foot-pounds. And this is also a press fit onto the receiver, so I can account for any slack that could be between the receiver and the barrel. This is just a standard. I have no idea who makes it upper receiver. I was told it was an Arrow. I don't know. I have it attached to a Picatinny rail primarily, once again, so that since I'm gonna have this upper receiver attached to a vice block or an upper receiver block. So the whole idea behind this is that if there is movement on the upper receiver to that vice block, the movement isn't gonna be translated over to the mount with the dial indicator. If the upper receiver moves, the whole mount will move with the upper receiver and with the barrel, so therefore the only thing you will be able to measure is the difference in movement between this barrel and the dial indicator. So that's how we're going to load it. I'm not going to need this tube that I made whenever I go up to this setup because I have Picatinny rail all the way up to here. So I'm going to be able to omit this tube. This I just made specifically so that I could measure something that doesn't have a handguard, case in point. Also, before I forget, I was supposed to show you what I was going to use to load the barrel. So I tried to think of a bunch of different ways that I could buy weights, maybe lead weights, something that would work. They weren't all exact measurements, so, and they were, you know, they're expensive. I mean, obviously I have gun parts to buy. So the best thing that I could come up with was a bottle that I'm going to fill with water. We're going to start at 2 ounces because this Gatorade bottle weighs 1.7 ounces. So I'm just going to add a little bit of water until I get 2 ounces. Most muzzle devices are 2 ounces, so we're going to start there just because everybody's going to be running a muzzle device. It's not going to be a perfect measurement, perfect scenario on this pencil barrel because I already have a muzzle device and no, I'm not taking it off. We'll act like this is 4 ounces, or you can just say whatever and start from there. I don't know for sure how much we're going to get as far as deflection when it comes to 2 ounces, but we'll find out. So this is going to be a learning experience for you and me. So let's continue and let's find out whether pencil barrels are a good idea for a suppressor in general. Okay, so I was finally able to get this zeroed out so that I can take the measurement. This is extremely finicky because the moment you touch it, it kind of moves out of position. I don't expect this to 100% return to 0 because normally these things, unless they're like super nice, which this isn't one of those, it's somewhat accurate, it's good, it's consistent, it'll get us a decent reading, but it's not going to be perfect, which once again, we're not going for perfection, we're just going for a baseline of, or an idea of what's exactly going on. So like I said, I have the Gatorade bottle, I have my scale, and then I have the dial indicator. So we're gonna turn it on, it's gonna zero out. You can see zeroed, 2 ounces, exactly. Which I'm trying to see if I can get rid of this glare. 2 ounces, there's a decimal right in there. It's 2.0 ounces. So, and I mean, really, how much could there be here? Nobody believes me. So we're gonna put it close to where the threads would be. Probably right about here. And we're already getting some deflection. You know, it's 2 ounces is already causing an effect. It's moving 1/1000th of an inch down. How thin is 1/1000th of an inch? That's like shim stock, like thickness. That's very small amount. Could this mean a lot at distance? Yes, this could mean a lot. So it's something to consider. Anyway, moving forward. So in 4 ounces, I'm accounting for, see, it doesn't fully return to 0, but you know, I gave you an idea of what the starting point was. I'm now reading 4 ounces over here. I got rid of the cap, but I accounted for it with water. It was 0.1 ounce of a difference. So we're gonna move it, put it on. Same location. So 0.0015, could that 0.15 be from the number that shifted to begin with? It could very well be. It's just hard to know for sure. I think the main thing we're going to start noticing is once we increase weight further. Six ounces. It's changing for sure. 2/1000ths. Apparently this was 6.1 ounces. So we're going to keep that in mind. I don't think that 0.1 ounce is going to make a difference. Eight ounces. 3/1000ths. 2, 3. I'd say 3. it off of this. It's 10.1 ounces. So just keep that in mind, it's 10.1. I'm not gonna go out of my way to get rid of that. I'll just account for it in the so incrementally as we add, seems like it's about 0.0005 of an inch every time we add 2 ounces. Like I said, this is not an exact science, it's just to see what the effects are so we can set up a curve. $12 ounces. Four thousandths. $14 ounces. Once again, every 2 ounces, we see 5 ten-thousandths. Thousandths. Let's try this again. Set it down gently. Okay, now we're at a pound. 16 ounces. This is a pound. So what kind of effect the pound has on it. Five thousandths. Now that's a significant amount. That's where I believe the suppressor starts coming in. Most suppressors start weighing in. This is 5 thousandths is nothing to shy away from. This is significant point of shift. It might not be huge at close distance, but it's going to be significant at distance. £1 pound, 2 ounces. So that would be 18 ounces total. £1 pound, 4 ounces is 20 ounces. Oh. Okay, still good. Funny, now I can see the barrel flexing, which is, I think, pretty hilarious. Well, that's 1 pound, 6.1. It is what it is. So I believe that would be right at the alley of a quiet bore. That's a significant amount. No, so that's a significant amount. Anyway, let's move on to the 10.5. See how much of a difference. Obviously, because this is longer, it's more leverage for it to move. So, although it may be a concern when you're running such a long pencil barrel, this may not actually be a problem at all with a 10.5. So, let's see how it does. Moving on to the 10.5. To emphasize, the 16-inch also had a 45 foot-pound barrel nut torque with also press fit, just like this one, to the upper receiver. And they have different gas blocks. This one's a set screw style, while the other one's a clamp on. But for the time being, I just installed them to the actual specs, in which case the superlative asks for 28 inch-pounds on the clamp on. And I believe the Faxon one is about 28 or 30 for the set screws. There's 3 set screws in the bottom. I don't have a gas tube. I highly doubt that's going to make anything because gas tubes just flow around there. But this could add rigidity to the barrel. This one could be the better suited barrel and probably the best option for what could take a suppressor better, because a 10.5, a standard 10.5 with the government profile, is just thicker from here forward. So is it worth it for you to, if you're still going to have the flex over here, which I unfortunately don't have anything to compare it with, but if the flex is going to be mainly over here, then why have all this extra weight? It seems like all this extra weight, this is a 0.625 journal for the gas block. Why have all this extra weight up here when you're already running a suppressor? Might as well save weight where you can, which is not going to affect anything. This is where I really truly believe there's not going to be any effect. This is for the 10.5. I think the 10.5 pencil barrel is going to be right on the money for a suppressed setup. So first things first, turn this on. As you can see, we're already zeroed. See what this bottle weighs. 2.1. I'm just gonna, for the sake of this, at least this time as starting weight, I should get rid of that 0.1. All right, 2 ounces right there. Let's find out. See, that's the problem with this. It's already fluctuating between the 5 and whatnot. So take that last 5 with a grain of salt. So there, 2 ounces, no shift. I wouldn't even count that 5 as anything. No shift. Let's go with 4 ounces. Four ounces. Really nothing. That's 6.1. I'm not going to mess with it. All right, so we now see a change at 6 ounces. See, the difference is that I think we saw that number right off the bat with 2 ounces on a pencil barrel. 8 ounces. No change. 10 ounces. Okay, same thing, virtually no change. 12 ounces. Okay, so now we see finally some change. Let's get this thing to stop moving. Okay. Let's go to 14 ounces. Okay, 14 ounces. 1 pound. Two thousandths movement. 1 pound, 2 ounces. Still 2 thousandths. This is 20 ounces. No effect whatsoever, just 2 thousandths. 22 ounces. Quiet bore, I believe. Nothing, man. It's really had no effect since 16 ounces, I believe. Makes no difference in the barrel. See if I can get the 24 ounce. Yep, 24 ounces with the cap. And this is just accounting for that muzzle device. If you had a 22 ounce can with a muzzle device, I'm gonna put it up, but I mean, that's a significant difference. We're talking about less than half for not that much different of a barrel length. I mean, it is a significant difference. It's 5.5 inches shorter, but those 5.5 inches shorter account for less than half of the barrel deflection. So what did we learn from this? Probably not much. What we learned is that, as expected, and sometimes these sort of things, these case studies are just to further prove what we already assume. Now, as far as the barrel or the suppressor affecting the barrel itself, this is 100% granted. Like, we can, right now what we've done is we've set the baseline for a pencil barrel and how it's going to react when you add a suppressor to it. Ideally, for us to gather more information and continue this case study, we would have to find more barrels and make their measurements and see how much they deflect compared to pencil barrel. Now, in any scenario, you would say a heavy barrel supports the suppressor better than a pencil barrel. 100%, but does it matter? It's hard to say. If you're going to be putting on and removing the suppressor, the pencil barrel, I would say, is a no-go. As far as a 16-inch barrel goes and longer, maybe somewhere between. The 10.5 didn't really have much of an issue, so I wouldn't. The 10.5 should be perfectly fine for suppressor with installing and removing, which is normally what you would do with like a 10.5 Mark 18 setup. However, with a longer barrel, which is more of a precision rig or some longer distance setup, I would advise the suppressor on-off as a no-go. This could be, even if you were running something like the suppressor that the Mark 12 uses, that it has a 0 point of impact shift, or if you are able to get a suppressor that has 0 point of impact shift, the pencil barrel is still going to be a no-go because it's going to droop the moment you put the weight on it, which means that no matter if the suppressor itself wasn't affecting point of impact, your point of impact will be altered by the fact that the barrel can't support the weight. Now, does this matter if you're always going to run the suppressor on and never going to remove it? No, just put the suppressor on and then you zero it with the suppressor on and you're fine. Like the majority of the things that caused the barrel to whip in the first place, as shown in the video in the description, was compensators or things that direct the gases up to the sides. If the bare barrel just moved around a little bit when it wasn't deflecting gases in several or one direction specifically. That's why I removed the A2 flash hider from mine when I originally had it, was because I saw that video, and although the A2 flash hider is technically a compensator to bring the gun down, if my barrel is doing this every time, is it really actually helping, or is it just moving the barrel up and down because the barrel's flexing faster than the gun can be forced down? So, do I suggest suppressors on pencil barrels? Yes. For a long-range gun, I would leave it on or zero it with the can, and then just leave it like that. For a 10.5, highly recommend it. I don't think there's that much of a shift, and I don't think there's going to be any shift really compared to a government profile. Now, if you had a heavy barrel Mark 18, then we're talking about something which I'm hoping in the future I can myth bust this theory, or theory bust, is that what we're doing now? Like I said, this whole thing was a case study. It was just to see what kind of effects we would have over a suppressor drooping on the barrel. Now, this doesn't answer our question regarding, well, what if the barrel gets hot? That's something that I'm gonna have to do some testing later to see if I get any kind of vertical stringing from the barrel itself getting hot, and then the extra weight, basically the metallurgy or the metal becoming a little bit more malleable. Not anything that's gonna trash it, but just enough to where the barrel might start drooping a little bit. So that's something that I'm curious about. I know that there's certain guns that have vertical stringing, and I believe that is because they are not free floated. I know the Romanian PSL is one of them. So I would assume that that's the main reason, is because it's heating up and then there's something pressing against it. I have no way of testing this without shooting, so that'll have to be for another day, at least until the ATF gives me a suppressor, which I'm waiting for at day 345. So ATF, please hurry up and give me my suppressor so I can do this testing. I will have a little bit more testing in the future. I do have a heavy barrel 16-inch that we're gonna test, and we're gonna see what the actual barrel deflection is like with the added weight. Thanks everybody for tuning in. I hope you guys like this kind of video. I'm hoping I can do a lot more testing. I've wanted to do barrel deflection with the suppressors, barrel deflection when putting up against the barricade. I want to see what kind of barrel deformation I'm getting when using a set screw gas block versus a clamp-on gas block, and I'm looking into torque specs. I want to make sure, and this is way later down the road, I want to make sure that the companies that are selling you products are actually torquing things to spec. So it's basically just a torque analysis of sorts. So if you like this content or would like to see further content like this, please subscribe. It will allow me to move forward with this. Make sure you guys are liking this sort of information. Anyway, thanks for watching. Comment, rate, subscribe. Thanks again.